is a new Python video, a number set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just going to show you the code of this. I haven't been making videos for long because of personal reasons. I'm not going to type this out again because that will just make this video too long. And look, the input new digits, I have to use that to space the numbers out. And this class, I don't think that's really necessary, but I like to put this in a class. So this is definition of how to draw the number 0. Oh, I forgot to say something. And a line in middle, it will draw a line in the middle of what it does is it goes backward, forward, and then it draws a line, and then the turtle is in the middle of the line. I use turtle. I require NumPy because it won't work using Python symbols. Square root because this involves trigonometry. And going forward, my font is 50. I can tell you because the size of my letters are 100 by 180. Look, 100 pixels by 180 pixels. And it has to be exact because if it's not exact, it won't work. And I put, and for number 0, I draw a half circle. I draw a circle, but that goes backwards because it's supposed to start there. And then red dot circle and 180. It does a radius. It makes a circle that's a radius of n, and for 180 degrees, that's half a circle. And red dot forward, n times 8 divided by 5 because 50 plus 50, 100, and then 50 times 80, 400 divided by 5, 80. So 180. Red dot circle and 90, that puts it back to where it should be. So what I'm talking about, where it should be, at the bottom bit, at the middle of it. Yeah. Number 1, line in middle. I draw a line and then in the middle. I use that function quite a lot for number 1, 2, 4 because it draws a line and then it's still in the middle and then it tells, and then for number 1, and this is red dot forward n times 3.6, red dot left 135, and then red dot forward n times s2, red dot back n times s2 because yeah, it's because Pythagorean theorem. If you imagine a triangle here of this is length 50 and length 50. Look, this is a half, and then 50 times plus 50 squared plus 50 squared is 50 squared plus 50 squared is 5,000. And the square root of 5,000 is 50 times square root of 2. And then it goes backwards that. And then for number 2, it's the same thing for this. I'm talking about this line, which is thread.forward n times 2 times s2. So line in the middle and then thread.back. And if you don't know what thread is, it's the turtle that I'm using. Python Turtle Graphics I'm using. It goes back, turns right, goes forward, and then because this code. And for how much it goes, line in middle and thread.back and thread.left 45, thread.left 45, thread.forward that much, this distance. So what I mean is n times 2 times s2, which is the square root of 2, and that would be square. So that's 100. So that's 100 times square root of 2. So that's approximately 141. And then for the left 45 goes forward. It goes forward because this is 100. It goes forward 50. It goes forward 50. Sorry about that. And it makes a circle to make the number 2. And that's computer. And the advantage of that code is that you can play around with it. You can play around with the numbers. You can make any numbers. You could probably develop a code for this. And I don't know how to do. Number 3, thread.circle and comma 90 minus 90. Because the number 3 is just made up of arcs of different sizes. This is an arc of 270 degrees. The turtle starts from here. It goes back. It does a reversal. It goes clockwise 90 degrees, and then it goes anti-clockwise 270 degrees, and then it goes anti-clockwise again. And when I put n, what n really is 50. Just to let you know. Look, thread.forward. So it's this bit I'm talking about to make the theme look nicer. This and pretty much it for the number 3. Number 4 is this triangle. I have to use Pythagorean theorem again and the sine cosine thing again. Tangent, because this involves trigonometry. And also, yeah, 7. So input new digit. And then I did an input new digit. That means it goes forward. So that means it goes forward, just like how it would when you type. So that means the function input new digit is to go forward until the digit when it would be written fits there exactly. And then thread.left 90, and then thread.forward it turns. It makes this triangle. And also, Yeah, friend.right 30, friend.back end times 3, friend.right 60, friend.forward. Yeah, and and this is a code for the oh goodness, the straight line for between the between the hypotenuse of the triangle. And when I say hypotenuse, I'm talking about the triangle in the 4. I'm talking about this longest edge here. Now for 5, I go back just like I have done in number 3, and rather than doing another circle instead, I code the turtle to go forward, thread.forward and times 8 divided by 5. It goes forward. It actually goes forward n, and it has to go forward 80 pixels. So if n is 50 pixels, so n times 8, 400 divided by 580, and then that right as a 90 forward, n times 2, and then I code the turtle to go back there without leaving a line, and then when I go to number 6, I did a bit of editing for this because it wasn't accurate enough. I used a variable head, and then n times 80 divided by 5 minus n times 3 divided by 2 times 1 divided by s3 divided by 2. And this is the inverse. I'm talking about the inverse of sine. It's the inverse of sine 60 degrees. And it's not inverse sine 60 degrees. They're two different things. Yeah. Thread.left 180. It makes a circle. Thread.left 180. And then it makes and it's facing left, so it makes a circle counterclockwise. So it makes a circle clockwise, and minus 600, and for 600 degrees, it goes backwards for 600 degrees. So what I'm talking about is this. So it starts here facing left, goes 90, 180, 270, 360, no, it's going like, for goodness sake. Anyway, it goes to this point, 600, yeah, so it goes like this. So 90, 180, 270, 360, and then does this again until this 600 bit. This would be 720. And then that's a 30 degree. I use sine for this again. And it's even more accurate. Number 7. Thread.pen up, thread.back, thread.pen. Number 7, that's quite an easy number. But if you look closely about the number 7, it's got this little bit of this, which we could ignore. That means I could draw a 7 like this. It's got this little bit because it's the square root of 3 times 100 is just only 7 pixels off 180. So 7 pixels down. And then for number 8, it's just 2 circles. number. It's only just number 3. It's similar to it's a number 3, but with these joined up. Alright, number 9. Thread dot circle L180. Thread dot circle. Number 8 is probably the easiest number to do here, because it's just 2 circles. Number 9, however, it's just number 6 upside down. First, I have to get the turtle to the right position so that it can successfully do an upside down 6. And then an upside down 6 is 9. So I get the turtle to the top of the 180 bit by 100 imaginary rectangle, and then I make it face left, and then I do that. I draw a number 6 there, and then it just goes back to the original position. That's the last number of this number set. And this number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see here. And I'm going to leave here. Please subscribe, please like, please, and comments maybe. That's the end. Goodbye.